Welcome again. So next video about RSA, how all this works, how all this is set up. So I'll show you actually the process of building the keys and explaining you what's private, what's public, and how RSA works with that. So let's suppose that some person A wants to use RSA for cryptography. Actually, this person will choose as a secret. It's very important that the person is the only one to know the value of P and Q, which are two different prime numbers. In the second step, the same person calculates N equal as P times Q. So you can see the difference there is between choosing P and Q as two prime numbers, calculating their product, and having the result have a public information. So we'll see why N can be public and P and Q can be kept private. Then from P and Q, always the same person can calculate very efficiently phi of n, because it's p minus 1 times q minus 1. Then choose E such that the GCD of E and phi of n is equal to 1. That is, they are co-prime numbers. This gives no specific information about phi of n, so E can be public. Then calculate D, which is actually the inverse of E with respect to phi of n. You will have examples later. Then it's all set up because in the private parts we have P, Q. Sorry for my poor handwriting. PQ, phi of n, and D. And the public part is N and E. So from that moment, all is set up on A's side, and actually A can publish this public key, which is N and E. So remember that for the encryption and decryption step, the public key is used for encryption only. So if anyone gets the public key, this person will be able to do the encryption step for A. For example, some person B or C or D or anyone can use the public key. So actually, publishing a key means anyone can send ciphered or encrypted messages to A. On the other side, for the decryption step, the value which is used is a value of D, and D is private. Only A knows the four values which are private, that is PQ, phi of n, and D. So anyone can send cipher message to A, and on the other side, as the value of D is private, only A can decipher or decrypt. Only A can decipher messages which are encrypted with N and E. That is, knowing N and E is not sufficient for getting the value of D. So if someone wants to decipher messages encrypted with N and E, the only way to proceed is to get the value of D, and the value of D is known only by A. Okay, so some of you might tell me that is it really impossible to get the value of D? The answer is actually yes, it's practically impossible to calculate this value, even if we know the mathematical steps which are used there, and I'll explain you why in the next video.